March 23, 1943. The air inside the conference room at Wright Field, Ohio, is thick with the smell of stale coffee and the sharper, more authoritative scent of starched wool uniforms. Outside, the roar of piston engines is a constant, patriotic symphony, the sound of America gearing up for total war. But inside this wood-paneled chamber, the mood is one of polite, unyielding skepticism. Aeronautical engineer Robert Chilton stands before a tribunal of senior USAF officers, a blueprint clutched in his hand like a sacred text. He is a man of science in a den of warriors, a civilian whose battlefield is the slide rule and the wind tunnel, and he is trying to sell them the impossible. He's an unassuming figure, his suit slightly rumpled compared to the crisp olive drab of his audience. His eyes, however, burn with the conviction of a man who has seen the future in a series of complex equations. He is trying to explain why he wants to fundamentally alter the propeller blades on the Republic P-47 Thunderbolt, the heaviest single-engine fighter plane in the world. A colonel at the head of the table, a man with silver temples and an eagle's sharp gaze, leans forward, tapping a manicured finger on the diagram Chilton has presented. He squints, his face a mask of disbelief. "Let me get this straight, mister." Chilton, the colonel's voice is a low baritone, accustomed to giving orders, not asking questions. "You're telling me you want to put wider blades on an airplane that already has a weight problem?" Chilton nods, his expression unwavering. "Yes, sir." Wider, shorter blades, with an entirely new airfoil profile. A low chuckle ripples through the room. The colonel leans back in his chair, a smirk playing on his lips. He looks around at his fellow officers, sharing a moment of collective amusement at the civilian's expense. "Son," he says, the word dripping with condescension, "that is, without a doubt, the most stupid thing I have heard all week." But Robert Chilton was right, and his stupid idea would not only silence the laughter in that room, it would transform the P-47 Thunderbolt from a sluggish disappointment into the fastest diving fighter of the Second World War. It was the engineering mistake that saved thousands of lives. To understand the sheer audacity of Chilton's proposal, you must first understand the crisis facing the P-47 Thunderbolt over the war-torn skies of Europe in 1943. The P-47 was a monster. There is no other word for it. It was, quite literally, the largest and heaviest single-engine fighter America had ever produced. They called it the Jug, short for Juggernaut, a name that spoke to its immense size and ruggedness. Empty, it tipped the scales at over 10,000 pounds for 1,500 kilograms. Fully loaded for war with fuel, 8.50 caliber machine guns, and a full bomb load, it weighed in at a staggering 17,000 pounds, 7,700 kilograms. To put that into perspective, the Luftwaffe's workhorse, the Messerschmitt Bf 109G, weighed a mere 6,000 pounds, 2,700 kilograms, fully loaded. The formidable Focke-Wulf 190, the infamous Butcherbird, was heavier at 8,600 pounds, 3,900 kilograms. The Jug weighed more than a Bf 109 and an Fw 190 combined in some configurations. German pilots, squinting up at the behemoth, had their own nickname for it, the Jabo, short for Jag Bomber, a fighter bomber. They saw it not as a thoroughbred fighter, but as a flying truck. American pilots adopted the Jug nickname with pride, patting the thick aluminum skin of their planes before mission. But in the quiet moments of the ready room, or in letters home, they confessed their fears. The problem was brutally simple. In air combat, altitude is life. The fighter that flies higher holds the advantage. He dictates the terms of the engagement. He can dive on his enemy, converting potential energy into kinetic energy, using gravity as his greatest ally. But to gain that altitude, you first have to climb. And the P-47, with its colossal weight, climbed like a dump truck full of bricks. A nimble Bf 109G could scramble to 20,000 feet, about 6,000 meters, in just 5.8 minutes. The Jug took a painful 8.5 minutes to reach the same altitude. That difference, a mere 2 minutes and 42 seconds, was an eternity in a dogfight. It was a death sentence for countless American pilots who found themselves caught low and slow, forced to watch as German fighters circled above them like sharks, waiting for the perfect moment to strike. If you want to discover how one simple, counterintuitive change completely flipped the script for this legendary warbird, smash that like button. It tells us you want more deep-dive, technical histories like this one. But the abysmal climb rate wasn't the Jug's only flaw. There was another, more sinister problem that pilots discovered in the heat of battle: compressibility. When a P-47 entered a steep, high-speed dive, something terrifying would happen. The controls would grow heavy, sluggish, then lock up entirely. Pilots reported a sensation like an invisible giant grabbing the control stick, refusing to let go. The plane was no longer flying. It was a 17,000-pound lawn dart aimed at the heart of Europe. This was the treacherous phantom of compressibility. At speeds approaching the sound barrier, air ceases to behave like a fluid gas and begins to compress in front of the aircraft surfaces. This compression creates powerful shock waves that disrupt the airflow over the wings and control surfaces, rendering them useless. The original P-47 had a terminal velocity limit in a dive of roughly 420 miles per hour, 680 kilometers per hour. Push it any faster, and the pilot entered a zone of no return. Many brave men were lost, their frantic radio calls cut short as their uncontrollable fighters slammed into the ground. This created a devastating tactical paradox. The Jug's immense weight should have been its greatest advantage in a dive. Basic physics dictated it. More mass equals more acceleration, a higher terminal velocity. The P-47 should have been able to dive away from any German fighter with impunity. But it couldn't. The laws of aerodynamics were betraying the laws of physics. The Jug was a powerhouse that couldn't unleash its own power because its controls would fail long before it reached its theoretical maximum speed. The physics said yes, but the aerodynamics said no. This is where Robert Chilton re-enters our story. Chilton wasn't a celebrity aircraft designer at Republic Aviation. He was a quiet, meticulous engineer specializing in propellers for a company called Hamilton Standard, the firm that supplied the props for the P-47. While Republic's top minds were desperately trying to solve the problem by redesigning the fuselage, the wings, and the control systems, Chilton was obsessed with the one component everyone else was ignoring: the propeller. The early P-47s used a four-bladed Curtiss electric propeller. It was a perfectly competent piece of equipment, but Chilton, poring over endless streams of flight data late into the night, had noticed an anomaly. At very high speeds, the tips of the propeller blades were breaking the sound barrier long before the rest of the aircraft. This created their own miniature shock waves, a chaotic vortex of turbulent air that streamed back over the wings and fuselage, contributing to the catastrophic control lockup. In essence, the propeller was actively sabotaging the airplane it was meant to power. Chilton's solution was pure, unadulterated engineering heresy. At a time when everyone believed that longer, thinner blades were the key to reducing drag and increasing speed, he proposed the exact opposite. He designed a propeller with blades that were shorter but significantly wider, almost paddle-shaped, with a greater chord and a completely redesigned airfoil. He called it the paddle blade. His calculations showed that these new blades would be slightly less efficient at low speeds. It was a compromise, but at high speeds, their shorter length and unique shape would prevent the tips from going supersonic. This would eliminate the parasitic shock waves that were strangling the P-47's performance. It was a gamble, a trade-off that flew in the face of conventional wisdom. When Chilton presented his proposal back at Wright Field, the reaction was exactly what he'd braced himself for: utter disbelief. The silver-haired colonel scoffed. "You're proposing to make the plane slower at low speed in order to make it faster at high speed?" he asked, incredulous. "That makes absolutely no sense." But Chilton had his numbers, and the numbers didn't lie. His calculations, scribbled on page after page of graph paper, predicted that the new propeller would push the Jug's maximum dive speed from a dangerous 420 miles per hour to over 470 miles per hour, 750 kilometers per hour. This wasn't just an improvement. It was uncharted territory for any propeller-driven fighter of the era. What Chilton didn't know was that the very same colonel who had laughed at his idea had a direct line to the top. He was a personal friend of General Henry Hap Arnold, the commanding general of the entire U.S. Army Air Forces. And Hap Arnold was a man desperate for any edge, any innovation that could give his boys a fighting chance against the seasoned pilots of the Luftwaffe. 3 weeks after that humiliating meeting at Wright Field, Chilton's phone rang. A clipped, official voice on the other end of the line informed him that his proposal, against all odds, had been approved for flight testing. On June 17, 1943, a P-47D-22, its nose fitted with the strange, new Hamilton Standard paddle blade propeller, taxied onto the runway at Wright Field. In the cockpit was Major Robert S. Johnson, already one of the leading aces of the 56 Fighter Group. Johnson had 7 German planes painted on the side of his regular Jug. He knew the aircraft's limitations better than almost anyone alive. He was the perfect man for the job. The test began at an altitude of 33,000 feet, 10,000 meters. The sky was a deep, brilliant blue. Johnson took a deep breath, radioed his status, and pushed the stick forward, pointing the Thunderbolt's nose directly at the green fields of Ohio below. The engine roared as he firewalled the throttle. The dive began. At 26,000 feet, the airspeed indicator read 360 miles per hour. Normal. At 20,000 feet, the needle crept past 420 miles per hour, the point where the standard P-47s began to protest, where the controls would start to feel like they were set in concrete. But Johnson's modified Jug remained perfectly responsive. The stick felt heavy, weighted with the immense pressure of the dive, but it was alive in his hands. He was still in control. At 13,000 feet, the needle touched 450 miles per hour. The entire airframe began to vibrate, a low thrum that Johnson could feel in his teeth, but it was a vibration of immense power, not of imminent failure. He held the dive. At 10,000 feet, he pulled back on the stick, the G-forces crushing him into his seat. The big fighter responded, its nose gracefully pulling up from the earth-shattering plunge. The indicated airspeed, as he leveled out, was a staggering 470 miles per hour, 756 kilometers per hour. When Johnson landed, his flight suit was soaked with sweat and his face was pale, but a wide grin stretched across his face. He climbed out of the cockpit, pulled off his helmet, and reported to the stunned engineers on the ground. That airplane, he said, his voice trembling with adrenaline, wanted to go faster. I was the one who decided to stop. 470 miles per hour. It was the highest speed ever officially recorded by an American fighter in controlled flight. To put that in context, the German Bf-109G could reach about 465 miles per hour in a dive, but with controls that were nearly unmanageable. The FW-19E could touch 480 miles per hour, but with a severe risk of the entire airframe ripping itself apart. Chilton's modified P-47 could hit 470 miles per hour with controls that still worked and an airframe that showed no signs of critical stress. The Jug could finally unleash its full potential. But the speed was only half the story. Subsequent tests revealed something that not even Robert Chilton, in his most optimistic calculations, had fully anticipated. The new propeller also dramatically improved the P-47's rate of climb. This seemed to defy his own theory. He had designed the propeller to be less efficient at low speeds, accepting a climb penalty in exchange for high-speed performance. But the flight data was undeniable. The modified Jug climbed a full 4% faster than the standard model. The explanation was beautifully complex. By eliminating the supersonic shock waves at the blade tips, the new propeller also drastically reduced overall vibration and parasitic drag across the entire aircraft. This massive reduction in drag more than compensated for the theoretical loss of efficiency at low speed, resulting in a net gain. It was a miraculous, unintended consequence. In August of 1943, the USAF placed a massive order. All new P-47s rolling off the Republic assembly lines were to be fitted with the Hamilton Standard paddle blade propeller. All existing jugs in service were to be retrofitted as soon as the parts became available. If you're still watching, you're one of the true fans who appreciates the technical details that truly won the war. Type Hamilton in the comments if you're just learning about this incredible unsung hero. The operational impact on the front lines was immediate and profound. The 56th Fighter Group, Zemke's Wolfpack, was the first to receive the modified P-47s en masse, and they noticed the difference on their very first mission. On November 26, 1943, 8 P-47s from the 56th tangled with a flight of 12 Bf-109s over the English Channel. The German pilots, confident in their superior aircraft, followed their standard tactic. After a brief exchange of fire, they broke contact by nosing over and diving away towards the safety of the clouds below. It was a tactic that had worked dozens of times against the old, sluggish Thunderbolts. The American fighters, limited by compressibility, could never follow them. But this time was different. This time the jugs followed. The German pilots, glancing in their rearview mirrors, watched in absolute horror as the enormous American fighters, once so easy to escape, not only kept pace with them in the dive, but began to overtake them. The hunters had become the hunted. 5 Bf-109s were shot out of the sky before the shock survivors could escape into the cloud deck. Not a single P-47 was lost. Lieutenant Colonel Francis Gabby Gabreski, who would go on to become America's top ace in Europe with 28 victories, described the transformation perfectly. Before the new propeller, he said, "When a German went into a dive, we'd wish him well and go look for another target. After the new propeller, we followed him down to hell if we had to." The combat data confirmed this incredible turnaround. Between January and July of 1943, before the widespread introduction of the paddle blade, the 56th Fighter Group shot down 47 enemy aircraft while losing 34 of their own, a kill ratio of 1.38 to 1. Between August 1943 and March 1944, flying the modified P-47s, the same group shot down 184 enemy planes and lost only 41, a staggering kill ratio of 4.49 to 1. The group's effectiveness had improved by over 300%. And it wasn't just the 56th. Every P-47 group that received the modification reported similar dramatic improvements. Colonel Hubert "Hub" Zemke, the legendary commander of the 56th, wrote in his monthly report for February 1944, "The wide-blade propeller has transformed the P-47 from a good fighter into an exceptional one. Our pilots now seek combat rather than avoid it." But perhaps the greatest validation came from the enemy themselves. In March 1944, American intelligence intercepted a report from the German General of Fighters, Adolf Galland, to the German High Command. The report issued a dire warning about the sudden, inexplicable change in the performance of American fighters. "The American P-47s have been modified in some way that is unknown to us," Galland wrote. "We can no longer escape them in a dive. Our pilots report that the Thunderbolts now pursue them at speeds we previously considered safe. Urgent investigation is required." The German investigation never identified the change. Their engineers looked for modifications to the engine, to the wings, to the control systems. It never occurred to them to look at the propeller. Robert Chilton never became a famous man. He didn't design a whole airplane. He never won a medal. He was simply a propeller engineer who noticed something everyone else had missed. But his stupid idea of making the blades wider and shorter saved hundreds, perhaps thousands, of American lives and sent an equal number of enemy aircraft spiraling to their doom. Sometimes the greatest victories don't come from revolutionary weapons designed from scratch. They come from obsessive specialists, toiling in obscurity, who master the details everyone else considers irrelevant. The colonel who had laughed at Chilton's proposal back at Wright Field never publicly admitted his mistake. But after the war, he sent Chilton a short, 2-line personal note. It read simply, "You were right. I was wrong. Thank you." The P-47 Thunderbolt ended the war with over 3,750 confirmed aerial victories in a European theater alone. It became the most effective American fighter in the ground attack role, destroying over 9,000 locomotives, 86,000 railway cars, and 6,000 armored vehicles. And all of that legendary performance was unlocked, in part, by a few inches of extra width on a propeller blade that one engineer decided to create when everyone told him it was foolish. What do you think of this incredible story? Did you know about the massive impact a simple propeller change had on the performance of the P-47? Let us know in the comments below, and tell us which other World War II aircraft you'd like us to analyze. Be sure to subscribe and hit that notification bell. Every week, we bring you more verified stories of the military